This is free response question number 3 from the 2025 AP Precalculus exam. These problems and solutions can be found at collegeboard.org. So feel free to pause the video, try the problems yourself, and then I will walk through the answers and how to get them. Okay, so this one says, for a guitar to make a sound, the string needs to vibrate or move up and down or back and forth in a motion that can be modeled by a periodic function. At time t equals 0 seconds, point X on one vibrating string starts at its highest position, 2 millimeters above its resting position. So personally, if I'm reading this and I'm doing the problem, I am going to, as I read through, if I get a piece of information that can help me, I'm going to write it down. So it says that it's at the highest position, 2 millimeters above its resting position. So I know that point F is where the highest position is. So I know that right there is going to be 2. It then says it passes through the resting position and moves to its lowest position, which is 2 millimeters below the resting position. So that tells me that J, my Y value, is going to be -2. And then point X then moves through its resting position, returns to 2 millimeters above the resting position. So at point P, we're back at 2. And then it says this motion occurs 200 times in 1 second. So part A is we're supposed to label the points T, H of T for these 5 points. So we have found, and then I know I'm going to add in here, these are my resting position points. So I know that the Y value is going to be 0. So now I need to find the X value. So it's saying that the motion is occurring 200 times in 1 second. So if the period of our function, we know that between F and P, it is going to vibrate like that 200 times per 1 second. So that means that the period would be 1 over 200. So there's 200 cycles that are happening within one period. So that tells us that this right here is going to be 1/200th of a second. So now we need to work backwards. So F is 0. So that's our starting point. And we know that our ending point is at 1/200th. So then halfway is going to be half of 1/200th. So this is where we don't have a calculator, so we've got to be careful with our fractions. But if I divide 1/200th divided by 2, that's the same as 1/200th times 1/2, which would give me 1/400th. Okay, and then to get point G, I know that G is half of 1/400th. So same idea, 1/400th divided by 2 or multiplied by 1/2. Oops. Multiplied by 1/2 is going to give me 1/800th. So point G is at 1/800th. Now K is a little trickier because we're not just taking half. We know that we have to take 1/400th plus 1/800th. So to add those, I need a common denominator, or I need to multiply this one by 2. So it's going to be 2 plus 1. So we get 3/800ths. The other way to think of it is G is at 1 over 800. You could write J as, so I'm going to put an or here. You could write 2 over 800. And you could write P as 4 over 800. So I'm going to put or there. You don't need both of those. You need to pick which one you want, but they will take any equivalent answer. So you could write it as 2 over 800 or 1 over 400, and you're going to get it right either way. Okay, so carrying over our points from the previous slide, part B asks us to find the equation, and notice that it's giving us that it's sine. So we're going to come back to that in a minute to think about where sine typically starts. So we want to find the values of A, B, C, D. Oops. A, B, C, D. Okay, so starting with A. A is our amplitude. So we know that from our resting position to our highest point, or our resting position to the lowest point, is going to give me an amplitude of A value of 2. Okay. B, we know that the period is equal to 2 pi divided by B. So the period in this case is 1 over 200 equals 2 pi over B. So if we're trying to find B, we can cross multiply here. So this gives us that B equals 400 pi. Okay. Now D, let's take D because that's the next easiest. D is basically if our midline was shifted up or down. So we know that our midline right here is at 0. So our D value is just 0. If we were shifted up or down from that 0 point, then our D value would be would be whatever value we're shifted up or down. Okay, so C is probably the toughest. So we are thinking about how sine starts at 0, goes up, down, and then back to 0. So K could be our starting point of our sine graph, or this point that doesn't have a label right here could be our starting point. So there are multiple answers that they will accept on this one, and so we can pick either one of those points and shift our graph. So if we picked this point right here, we want our graph, we would want our C value to be 1/800. And we know that we're shifting it to the right to get it to that point. So that would be a positive 1/800. The other options, so this is one option. The other options, we could say A equals 2, B equals 400 pi, C equals, we could get it to that K value. So now we're shifting it backwards 3/800ths. So that would be negative 3/800ths, and D is still 0. So that's another option. The third option is actually to pick point G and then flip it. So ran out of space here. So let's look at that. That would be saying that A is negative 2, B is still 400 pi, C would be negative 1/800ths, and D would be 0. So those are all different possibilities for that same problem. Okay, C says to refer to the graph of H in part A, T coordinate of G is T1 and T coordinate of J is T2. So if we go back here, G to J is what we're looking at right there. So if we sketch, we're looking from this point to this point. Oops. So G to J. So it's asking which of the following is true about H. So notice we have to be very careful with the wording here. It's not asking about rate of change. It's just asking about our function H. So our function H in that case is negative. So our Y values are negative. So it's negative, and our graph is going down. It is decreasing. So our correct answer would be D, is negative and decreasing. Now, part 2 says on the interval T1 to T2, describe the concavity of the graph of H and determine whether the rate of change is increasing or decreasing. So now we're talking about rate of change. So between G and J, we would say that is concave up, which means that the rate of change is increasing. Okay, so that is for response question 3.